Hello everyone, welcome to my channel. Today we're going to do the adjustment of a quadrilateral. So for a quadrilateral to be approximately adjusted, there are two conditions that must be satisfied. First is the angle condition equations, and then the second is the side condition equations. In the angle condition equations, the sum of the 8 interior angles must be exactly 360 degrees, since in our formula determining the summation of the angles in a polygon, we have n minus 2 times 180, and since we have n as 4, minus 2 times 180 is 360 degrees, then the summation of all the angles in this quadrilateral should be equal to 360 degrees. So from the four overlapping triangles ABC, BCD, ABD, and ACD, we can get this equation. So um, let's start with ABC. So from the triangle, A, B, and C, we have interior angles of A, B, C, and D. So the summation of these angles is equal to 180 degrees since it is a triangle. So the same with the triangle BCD, BCD. So this triangle BCD, its interior angles are C, D, E, and F. So the summation of these interior angles is equal to 180 degrees. The same with triangle ABD and ACD, where your ABD is this one, ABD, and your ACD is this one. So since n is equal to 4, or n number of sides in a polygon, the summation of our angles is equal to 360. Considering the opposite angles at the intersection of the diagonals, so since this is our diagonal 1 and this is our diagonal 2 and that is their intersection, the summation of their opposite angles are the same. So in this case, we have opposites A plus B is equal to summation of E and F of their opposite side. So the same with C plus D is equal to the summation of their opposite side of their diagonal, H plus G. In angle condition equations, the corrections to the angles to remove discrepancies in the closure of the triangles are computed by the following equations. V1 equals V2, which in this case are the corrections to be applied for angles A and B, is equal to 1/4 of L1, or their errors of closure, minus 1/4 of L2 minus 1/2 L3 minus 1/2 L2. So if you notice in our equations, so in this case V3 is for the correction of angle C, V4 for angle D, V5 for angle E, V6 for F, V7 for G, and V8 for H. So in this case, we have our rotation. So if you have noticed in our formulas, the only difference is how this value or this formula is added or subtracted to our first term. So we can just assign it as k, or a constant value. So rewriting these equations, we can then get 1/4 L1 minus k. And this one also 1/4 L1 plus k. For our V5, V6, V7, and V8, we can then simplify it into 1/4 L3 plus k, 1/4 L3 minus k. Then after the angle condition equation is met, it is followed by the side condition equations. So the sine of each angle must be proportional to the length of the opposite side of that triangle. The sine of your angles from the left, or the left angles A, C, left, okay, E and G, is equal to the product of the sine of your right angles B, right side angles D, F, and H. And if you're going to divide both sides by the product of the sine of the right side angles, it would be equal to 1. If the logarithms of both members of the equations are considered, then log sine A plus log sine C plus log sine E plus log sine G, or simply the summation of the log sines of your left side angles, minus the summation of the log sines of your right side angles B, D, F, and H, is equal to 0. Unless this condition is satisfied, the value of a computed length will depend on the triangles used in the computation. It is evident that a correct adjustment to meet this condition will require angle corrections, which vary in size since the sines of small angles change more rapidly than do the sines of large ones. So let's proceed to an example so we can further understand how the adjustment of quadrilateral works. The observed angles of a quadrilateral after station adjustment are given in the accompanying tabulation and sketch. Adjust these angles by use of both angle and side equations. So the first thing to do here is to get the sum of the angles in the triangles or the overlapping triangles. For triangle ABCD, for triangle ABC, we have here this one, ABC triangle. Okay, for that triangle, we have angles A, B, C, and D. So their sum should be equal to 180 degrees. And if not, a correction shall be applied. So A plus B plus C plus D equals 42 degrees, 38 minutes, 36 seconds, plus our angle B, 64 degrees, 52 minutes, 28 seconds, plus our angle C, 40 degrees, 32 minutes, 57 seconds, and our angle D, 31 degrees, 56 minutes, and 7 seconds. So the summation of the angles in the triangle ABC is equal to 180 degrees and 8 seconds. So there is an error of 8 seconds here. So the difference, or the L1, is 180 minus summation of angles in triangle ABC. Okay. So 180 minus 180 degrees, 00 minute and 8 seconds is equal to negative 8 seconds. And for triangle BCD, For triangle BCD, we have angles C, D, E, and F. So for triangle BCD, the summation of angles in triangle BCD is equal to C plus D plus E plus F, which is equal to, just simply add this, C plus D plus E, and F. So your answer would be equal to 179 degrees, 59 minutes, and 48 seconds. So the correction or the difference between 180, so your error in that triangle is equal to 180 degrees minus the summation of the angles inside BCD, which is equal to positive 12 seconds. So we're going to use this L2. If you remember our formula, that formula, we are going to use those. So next is for triangle CDA. CDA. C, D, and A. So in angle condition equations, 7 angle conditions may be formed. However, if any 3 of these equations are satisfied, the others necessarily follow, and therefore only 3 equations are really required. That is why we are stopping at triangle CDA. So we only used, or we only get the use the triangles ABC, BCD, and CDE. So for our triangle CDA, we have the summation of angles E, F, G, and H. So E plus F plus G plus H. And their summation of these angles is equal to 179 degrees, 59 minutes, and 56 seconds. So the error is equal to CDA is equal to positive 4 seconds. Okay, let us just rewrite our L values. For L1, we have negative 8 seconds. For L2, we have, or we got positive 12 seconds. For L3, we got positive 4 seconds. Substituting this to our constant k, this is our k. So k is equal to 1/4 times L2 minus 1/2 of L3 minus 1/2 of L1. So substituting our values, L2 is positive 12 seconds minus 1/2 of L3 minus 1/2 of L1. We get our k as equal to 3.5 seconds. So substituting our k value to our angle condition equations, we'll get for V1 equals V2. For V1 and V2, we'll get 1/4 of L1, 8 seconds, minus our k, 3.5 seconds, minus because of our angle condition equation. So we will get the correction negative 5.5 seconds. Corrections for A and angles A and B. So these angles. Next is the corrections for angles C and D, or V3 and V4. So 1/4 of our L1, same, minus, I am sorry, that is plus already, plus our K, we will get positive 1.5 seconds. So this is our correction for angles C and D. Next is the correction for our angles E and F, or V5 and V6. So 1/4 of our L3, which is 4 seconds, positive 4 seconds, plus our K of 3.5 seconds, we will get 4.5 seconds, positive 4.5 seconds. So this will be the correction to be applied for our angles E and F. Next is for our angles G and H. We have 1/4 of L3 minus our K. So this is equal to negative 2.5 seconds. Our K, by the way, is 3.5. Sorry, forgot to. Let me erase that. Okay, our K is 3.5 seconds. So our correction for the angles G and H is equal to negative 2.5 seconds for angles G and H. So rewriting our corrections for our angles, we have negative 5.5 seconds, negative 5.5 seconds. For our angle C and D, we have positive 1.5 seconds. For our angle E and F, positive 4.5 seconds. And for angles G and H, we have negative 2.5 seconds. So our new adjusted values of our angles in the quadrilateral, just simply adding this column to our observed values, we will get. So angle A prime is angle A plus V1. And our A is 42 degrees, 38 minutes, and 36 seconds plus our V1, which is equal to negative 5.5 seconds. So our A prime, or our adjusted value of A, is equal to 42 degrees, 38 minutes, 30.5 seconds. So rewriting that in our tabulated solution, we have 42 degrees, 38 minutes, and 30.5 seconds. So next is our B prime, or the adjusted value of angle B, is equal to B plus our V2. Our V2 is the same with our V1, which is equal to 64 degrees, 52 minutes, 22.5 seconds. So for our angle C prime, the correction to be applied is our V3. So C plus our V3, if our C is equal to 40 degrees, 32 minutes, and 57 seconds, plus our correction of positive 1.5 seconds. So our new angle C after the angle condition equations adjustment is equal to 40 degrees, 32 minutes, and 58.5 seconds, and so on and so forth. So after applying the corrections that we have that we calculated, that we have computed, you will get these values. Okay? But we're not yet done, because we're still going to adjust these angles using the side equations. So after we have done the adjustment using the condition equation, we're now going to adjust again the quadrilateral using the side condition equations. So let us arrange our table, or our data. So in this side, we have the left side angles, and on this side also we have the or the right side angles. Right. Okay. So we are going to follow 3 steps in solving or adjusting our angles with using the side equations. First is, again, arrange the tables. Arrange or tabulate your data for easy calculation. Next is, we are going to get or compute for the log signs of each angles. Log sign computation. Next is tabular difference for 1 second computation. And next is get our difference of the sums, these sums. And our last is apply the corrections. Okay, so let's start with the log signs. Simply get your calculator and input the log at base 10 of sine of angle A prime. And our angle A prime is equal to, since our angle A prime is equal to 42 degrees, 38 minutes, and 30.5 seconds. Okay, so input that in the calculator and, okay, let me get my calculator. So log 10 sine of 42, 38, 30.5. You will have log sine equals to negative 0.1691465551. Okay, so after calculating that, the log sign, let's get the tabular difference per 1 second. So in order to get that, simply input this in your calculator. Tabular difference of your angle A prime. Okay. Angle A prime plus 0 degrees, 0 minutes, and 1 second, since we're talking about the difference of 1 second here. Okay, minus the log sign of your angle A prime times 10 to the power of 7. You will get 22.8637317. So after computing all the log signs of our angles as well as the tabular difference per 1 second, the next thing to do is to determine the difference of their sums. So let's name our sums as sum 1, sum 2 for our log signs, then sum 3 and sum 4 for our difference for 1 second. Okay, so to determine the correction, we have to determine first the difference. So this is the formula for the correction to be applied to our angles. Okay, so first determine the difference. Our difference is equal to the difference of your sum 1 minus sum 2 times 10 to the power of 7. So in this case, our answer, we will get 8.76. So substituting this one to our equation for the correction, we will get 8.76 over sum 3 plus sum 4. Remember, our sum 3 and sum 4 are the sums of our difference for 1 second. And we will get a correction of 0.048 seconds since this is in seconds. Okay. So how do we know how to apply these corrections? How do we know if we're going to add them or to subtract them from our angles?